Let's work on question 2.2 now. So we have a firm that's located on a riverbank and it produces chemicals which it can sell at a price of $12 per ton. Now production costs 1/2 quantity to the power of 2, but this production pollutes the river and the level of the pollution is given by W equals to 1/2 times the quantity. Now downstream a farmer uses the water from the river to irrigate his land, and to prevent the damage he must have clean water. Removing this pollution costs C equals to W to the power of 2. Now in part A we want to show in one figure the marginal private benefit, the marginal cost, and the marginal external cost. Now we have the data over here. One thing we have to understand is this sentence: removing pollution cost C equals to W squared. What does it mean to remove pollution? It means that that pollution is worth W to the power of 2. And what is W to the power of 2? Well, that's a function of the quantity, which depends on the pollution. In other words, this thing causes the damage. Reducing the pollution means reducing the damage from producing the chemicals. So how can we find out the total damage from here? Well, we will substitute the W into the damage function. So we will have the damage equals to 1/2 times the quantity, which is the W, to the power of 2. So to the power of 2. Now what is that? Damage is equal to 1/2 to the power of 2. That's 1/4 times the quantity to the power of 2. So that's quantity squared. So this is our damage. Now with this in mind, let's solve this question in part A. We want to draw on a graph the marginal private benefit. Well, the marginal private benefit is how much we make from selling one unit, and that's the $12 over here. This will be our marginal private benefit. Now, what's going to be our marginal private cost? Well, the marginal cost of production is going to be equal to the derivative of the cost function with respect to quantity. So that's the cost function derivative with respect to quantity, which is equal to 1/2 times Q squared derivative with respect to Q. We keep the constant 1/2 times Q squared derivative with respect to Q. That's just 2Q. 1/2 and 2 cancel out. So these two cancel out, meaning that the marginal cost is equal to the quantity. What we also want is the marginal damage. So we go over here below. We also want the marginal damage. And the marginal damage is the derivative of the damage function with respect to quantity. And we know that the damage function is over here, 1/4 times Q squared. We differentiate that with respect to the quantity, so we get as a result 1/4, which is the constant, and Q squared derivative with respect to quantity, that's just 2Q. 1/4 times 2Q, what's that going to be? Well, 4 and 2 cancel out, so we're left with 1/2 times the quantity. And now we have all the data to plot on the graph, so let's do that right here. We will draw it over here below. So we have the relationship between the dollars and the quantity. Now we know the marginal private benefit that was worth, as we said, the price that we sell it, and that's $12. So we will plot a straight line at $12. It's a fixed marginal benefit, so that's going to be 12 over here. That is our marginal private benefit. Now what is the marginal cost of production? Well, that's just the quantity, meaning that the slope here is 1. That's Q times 1, and a slope of 1 means a vertical line at the 45-degree angle, so it will look something like that. That's the marginal cost. And the marginal damage, as we said, is 1/2 times the quantity. So 1/2 is a smaller slope as 1, smaller than 1, so that means that the line will be flatter. So 1/2 will be somewhere over there like that, and that's going to be our marginal damage. Now we'll stop here in this video. In the next one we go on with part B.